The night Ben Rich changed my view about Einstein's relativity theories. He ended a 1993 presentation where he covered his 40-year career at Skunkworks, his lifetime of high-tech aircraft and stealth, with this bombshell. We found an error in the equations. We now have the technology to take ET home. We can travel amongst the stars, and it doesn't take a lifetime to do so. When I heard of this well-documented statement through reliable sources, my mind fired up, and my first thought was, if that's true, we need a new map. We need to take a revolutionary view and approach as to how we engineer atmospheric and space travel. Stick with me here because what I discovered, the theoretical gravity control system, I believe this actually holds up as a plausible gravitational control system when used in conjunction with Tesla's electric universe model, and this is how they do it. Subscribe, share if you also see the plausibility of this theory by the end of this video. My search for the error in the equations Rich spoke of initially started with Einstein's special and general relativity theories. Going back to Ben Rich's statement, we can travel amongst the stars and it doesn't take a lifetime to do so, can only mean one thing. Einstein's relativity theories could be the error. Einstein's house rules are clear. Nothing can travel faster than the speed of light. If star travel doesn't take a lifetime, those rules have to be wrong. So I set them aside, not as heresy, as scope. Once Einstein's universe model was out, that left Tesla's electric universe model, and this is where everything started to come together. It was like finding one of the missing pieces of the puzzle. Next stop, James Clerk Maxwell, 1831-1879. Electric charge shapes space. Put charge on plates, electrodes, and you sculpt the electric field. This is the plan to create the bubble dome shape. Magnetism has no single poles. Coil return paths must be tidy. This keeps the axial field clean and stable. Changing magnetic fields make electric push. When fields swing, they induce voltage. This will be useful during pulse collapse for energy recovery. Currents and changing electric fields make magnetism. Axial pulses, fast current plus fast E-field changes, build the magnetic backbone of the push. This avoids the need for spark gaps. Displacement current, Maxwell's add-on. Even where no wire runs, a rapidly changing electric field acts like current. Translation: strong, fast pulses still build magnetism through air or vacuum. The plan is to use this for a shaped near-field bubble. Where the energy goes, electric and magnetic fields carry and shuffle energy. Good pulse design keeps that energy circulating locally. Store, push, recover, avoiding spray-away leakage. Fields can push on matter. Organized E and B fields create pressure and tension on surfaces and in air. That's the legit path to real shove on propulsion. Air, ion, wind, EHD, in atmospheric conditions. Pads, chock rails near surfaces, field coupling. Tiny propellant in space when you need honest reaction mass. Timing, power. Phased pulses across stations create coherence. So individual nudges add up into one strong axial column. This S, the axial pulse array. Edges matter. The way fields jump across materials, metal, air, fairing, decides whether your bubble hugs the hull or experiences leakage. Geometry matters because it equals control. Near field versus far field. Stay near field dominant to keep energy local and recoverable. If you radiate, you lose lift as broadcast slip. What Maxwell doesn't do, he doesn't turn gravity off. In this build, EM is your engineered push. The Tesla EU lens is what will be driving the medium. I knew there had to be more, because this still didn't fill the gap. There's still a missing link, and while continuing my quest looking for errors in equations, I recalled something I had read many years ago. André-Marie Ampère, 1775-1836. It was his work that led me to the theoretical gravity control system I am going to share with you here. André-Marie Ampère built bench experiments to quantify how currents act on each other. Not just magnetism, but direct forces between current elements. Parallel straight wires showed attraction for currents in the same direction and repulsion for opposite directions. The baseline to separate sideways, transverse, from along the line, longitudinal, electrical current effects. Current balance apparatus, Suspended conductors so tiny force components could be read like a scale, used clever circuit layouts to cancel transverse pieces and leave any along the wire push, bar, pull detectable. End-to-end, head-to-tail geometry. Arranged short current segments collinear, in line with each other, with remote returns. From the measured deflections and symmetry arguments, inferred a repulsive component along the common axis when elements are head-to-tail. Coaxial helices, solenoids, tests. Wound, tight coils, and oriented them so some turns are effectively head-to-tail. Observed net forces that couldn't be explained by side-by-side attraction alone, indicating a longitudinal contribution survived the geometry. Angular Dependence Law, 1822 memoir. Formulated a force law between current elements that depends on their relative angle and separation, acts along the line joining them, and strictly obeys Newton's third law, equal and opposite, a form that naturally includes longitudinal terms for head-to-tail arrangements. Null and reversal checks, reversed current directions, swapped coil orientations, and reran the balance. Sign flips match the predictions only if an along-axis component is included. Ampere treated electrodynamics as action between currents, forces along the join line, not purely as fields acting sideways, so the longitudinal piece is explicit in his framework. Later vector field formulations largely emphasize the transverse JXB part. GR benchwork, not armchair mathematical beautification formulas Ampere had discovered. Two roads, sideways attraction, and the head-to-tail push-pull along the current, a longitudinal force almost no one talks about. Reading Assis's translation, something clicked. Tesla spoke of an electric medium he called the ether. This is what modern mainstream science refers to as quantum. It's all around us and throughout the entire universe. Think of it like the empty that's everywhere. It's space that responds when you interact with it, so to speak. This is the place where this theory lives, breathes, and theoretically works. What transpired is not gravity turned down, but a pulse push turned up. Ampere gives the straight push. Tesla gives the stuff to push through. Gyros and vortices. They can look like anti-gravity, but they are only pressure and inertia tricks. These were good lessons, but they were not the key. However, the way they can mimic anti-gravity was a clue, and from these, a broad concept was born. Here's the system boot and pre-flight and phase map checks. AFT-EU gravity control. Phase map theoretical. 1. Boot and health check. Spin up prime power. DC bus stable. Self-tests. Caps. OK. Drivers OK. Station wiring OK. Cooling OK. EMI shields OK. Safety interlocks armed. Hard discharge path standing by. 1. Geometry and bias. Prep set. Hull rush return geometry and bring up a light bias field so the bubble has a clean shape to form into. No lift yet. Edges conditioned to prevent stray arcs. Sensors zeroed. 1. Capacitor precharge. Capacitor farm fills to target voltage. Ripple filters settle. SOC confirmed. Recovery network. ERN. Idles. Ready to harvest after each pulse. 1. Clock and phase lock. Master clock online. All axial pulse stations locked to the same reference. Frequency locked and phase aligned, with controllable phase offsets for vectoring. Stations PLL locked to the same frequency and phase. Phase map loaded. Which station leads lags for hover versus vectoring. 1. Soft ignite. Pilot pulses. Very low amplitude axial pulses to sniff the medium. Verify timing, polarity, and station responses. Tune out any jitter. Confirm the Ampere longitudinal push signature. 1. Bubble formation ramp. Gradually raise pulse amplitude and repetition until a stable force bubble appears. Closed loop controller trims for smoothness. No surges, no leaks. 1. Choose coupling mode to make real lift. Air, ion EHD. Enable edge ionization, gentle electric shove in atmosphere. Field pad, track. Engage pad coupling for silent levitation relative to ground. Space, arm, tiny propellant cartridge, if needed, for honest reaction mass. 1. Hover lock. Hold altitude with micro adjustments to pulse height. Duty, phase. Bubble is steady. Energy recovery windows open after each burst. 1. Vectoring arm. Allow per station bias. Any one axial pulse station can go slightly brighter or earlier. Control laws active for pitch, jotch, roll, yaw, strafe. 1. Translation and maneuver. Bias one station. Bubble leans that way. Slide, climb, turn, disc or triangle. Chugs, same control. Paths blended by tiny changes in amplitude and phase. Vector by phasing. 1. Cabin comfort bubble. Inner, low power bubble runs slightly out of phase to soften G-hits during aggressive moves. 1. Energy recovery, Maxwell collapse. After each pulse train, the field collapses. Induced energy is pulled back via the energy recovery network into the caps. Bus SOC topped, thermal budget updated. Push with Ampere, recharge with Maxwell. 1. Thermal and field, housekeeping. Cooling loops trim hotspots, EMI monitors keep emissions in bounds. Edge conditioning rechecked, geometry nudged if needed to keep the bubble tight. 1. Mode transitions, hover, cruise. Station keep, handled by scripted ramps. No sudden step changes. Coupling can switch, pad, air, space, with pre-planned handoffs. 1. Fault handling, if anything drifts. Auto-detune the hot station, redistribute load across others. If jitter grows, drop to soft ignite level, relock timing, climb back. If a hard limit trips, safe discharge, bubble collapses, craft reverts to backup support. 1. Graceful shutdown. Throttle pulses down in stages. Last recovery window tops the caps for next start. Discharge to safe. Bias fields off. Cool down. Log saved. First I needed a force, then I needed way to control that force. So specialized capacitors became the heartbeat. High-rel hybrid capacitors. Quantic Evans cap. Pulsed, low ESR, hermetic. High voltage pulse film capacitors used in radar. Charge storage for TR modules and pulsars. Ultracapacitor burst power. Military, WAS, to buffer stages ahead of HV supplies. A combination of these is needed with the 30 kV long efflux rings power generator that I have designed to power the GCS gravitational control system. These cap banks charge quietly and directionally powerfully pulse discharge cleanly. The system will also need solid-state drivers that will keep perfect timing, eliminating spark gaps, just clean, tidy precision. The design includes axial pulses, tight, straight electric pushes arranged head to tail. One pulse, one nudge, and adding to the theory, I stack them and fire them in phase. These pulsing nudges add into a steady column of push. Shape that column with careful geometry and you get a force bubble, a safe zone where our push helps against weight, not anti-gravity. Pro-push forces. Inside, things that couple to the field feel lighter. Outside, nothing mystical, just an organized force. Force without coupling is poetry. To do the work, the bubble must push on something. In air, we guide ions for a clean electric shove. We react against an external field for silent levitation. In space, a tiny propellant feed gives honest thrust. Choose what the mission needs. Whether it's disc or triangle shaped, the control law is the same. We've got 3 phased force lobes. Feather one brighter or a hair earlier, and the force bubble leans that way. Slide, climb, turn, no rotors, no roar, just aimed force. You will notice this mirrors Bob Lazar's description of a disk with a central reactor and 3 underbelly emitters. Bias one emitter and the craft leans into that lobe. Hover, tilt, translate, quietly. In our theoretical model, those emitters are axial pulse stations, phased by electronic circuits and capacitors to steer the force bubble the same way. What if theorized must be pretty close to how that craft really works? What do you think? Bob uses the term gravity amplifiers, which in my model simply equals axial pulse stations. Phased field emitters powered by capacitor timing that shape and steer the force bubble. Same unit, different name. A smaller bubble runs slightly out of phase in the cabin. When the craft maneuvers, The cabin softens the forces. Some might call it an inertia damp. I call it captain crew courtesy phase. Flip pulse polarity. The push flips. Detune timing. The bubble wilts. Add stations, cleaner pulses, colder parts. The bubble grows. That's theoretic plausibility. Yes, a controllable force bubble from a capacitor-timed axial pulse array. Yes, real lift when we couple to air or a tiny propellant. No, we don't turn gravity off. We outpush it where we choose. Capacitor banks, the heartbeat. Solid-state pulse drivers, no sparks. Axial pulse array, ampere longitudinal. Force bubble shaper, geometry. Coupling module, air ion, tiny propellant. Vectoring, 3 stations, disk or triangle. Cabin bubble, comfort. Cooling and phase lock feedback. I call it AFTEU, Ampere Force X Tesla Electric Universe. Capacitors keep the beat. Solid-state drivers keep it clean. Axial pulses stack the straight line shove. Geometry bottles it into a bubble. Coupling turns it into thrust. 3 stations steer. A cabin bubble calms the ride. Cooling and feedback keep it in tune. Of course, this is only a first draft theory and hypothesis. It's simply a general overview. A map with all 3 axes, Tesla's medium, Ampere's straight push, and the capacitor heartbeat to hold them together. We're not turning gravity off. We're learning how to stand up to it, cleanly. Part 2 of this high-tech vehicle at this stage will be a theoretical EU-based ether DC power loop, ADPL, power system. A Tesla-flavored closed electrical loop that feeds an axial pulse array with huge clean DC and recovers energy between pulses. But I'm open to any better ideas if you'd like to leave a suggestion in the comments. Don't forget to comment, like, and subscribe. Who knows, it's not impossible for a scaled-down toy drone-sized prototype to be built as a proof of concept. Of course I can't do this alone. What do you think? Is this a plausible model?